Welcome back. We plotted some lines last time. Now we're going to see about plotting planes on our stereographic projection.
And I'm showing here the plane that we plotted in the section on calculations with lines. That's a plane with a strike 014. 38 east is the dip. That's shown in black here. I've added east here just as a check. It's really redundant in right-hand rule, but I often find it's helpful, especially in field observations, to record the general direction of dip when you're recording strike and dip by right-hand rule as a check. So here is the plane, and I'm going to add a pole here. So I'm going to select my black cross to match the black plane, and I will clone up here to create a clone of the black cross, and I'm going to drag it down. Now this has a dip of 38 degrees, so the great circle is 38 degrees in from the primitive, so my pole has to be out 38 degrees from the center of the net, which puts it about there. So let's now select the net and we'll return it to its starting position. And now we're going to see about plotting this second orientation, a strike of 168 and a dip of 21. And that's a dip to the west, because when you're looking on 168, you're looking almost to the south. So if you kind of mentally turn yourself around, if you look at your right hand, it's going to be pointing out to the west somewhere. So let's plot that in red now. So this time I'm going to rotate my net. I'll do it with the rotation tool here. I actually have it already set up, and I will apply the rotation. And so the net has now rotated 168 degrees. So you notice that the little curve here telling you which side to plot the great circle, that's now to the west, as we expect. So we're going to go to our pen tool, make sure the Spiro path option is selected, and I'm going to click 3 times. This time I've got to do a plane that is dipping generally to the west, and we've got to dip 21 degrees in from the primitive, so that's 10, 20, 21. It's just about there. And my third point is going to be down here. And I will right click to let go, and there is my plane. Now it's got itself filled in with red because I had red fills selected, so I want to have a red line around the edge. So I'm going to turn off the fill by clicking this big red X down in the bottom left hand corner. To make the line visible, we need to hold the shift key down while selecting the color that we need. So let's see about putting the pole to this one on the net. So I'm going to get hold of my red X here. I will clone it as before to make a copy, and I'm going to bring it over here. So this plane was dipping 21 degrees in from the primitive, so my pole has to go 21 degrees out from the primitive. So the first thing we can do with two planes is to find their line of intersection. So every pair of differently oriented planes has a unique line of intersection, and as you may be able to guess, that line of intersection is where the two great circles intersect. So I'm going to drag a differently colored X symbol here, maybe this green one. I'll clone it as usual, and we'll drag this down, and I'm going to put it right on where those two lines intersect. I may want to zoom in a little bit and then scroll the screen to see if I'm putting it in the right place. That looks pretty good to me. So there we have the line of intersection of two planes. If we want to find out the orientation of that line, that is its trend and plunge, we can click the net twice and turn it around and carefully place that arrow that marks the top point of the net, and I'm going to zoom in a few times just to see if I've done it right. That looks pretty good, and see what it's pointing to, and it's pointing to 180, 182, 184, 185, I think 186 to the nearest degree. So my trend is 186, and then the plunge is going to be 2, 4, 6, 7 degrees. So the line of intersection of those two planes, I can grab my text tool and perhaps record it down here. Line of intersection was 186. I usually record lines with a dash, and 07. And we always write plunges with 2 digits. We always write trends with 3 digits. Now that writing looks a little bit big and clunky, and that's because I've written it with a red outline, the same as I used for my line here. So we're going to give that text a black fill first by clicking on the black, and then we're going to take away the outline by holding down the Shift key and clicking on the X, and there our line of intersection is much smarter. And perhaps we should color that in green, because that was the color of our little X. So I'm going to pick a green color here, and then we'll have our answer in green. So that is the line of intersection of 2 planes. So for any 2 planes in 3-dimensional space that have different orientations, like the cover of my notebook here, we've just found their line of intersection, which would be the spine of my notebook. We can always find a unique plane that is perpendicular to both of those 2 planes. And the pole to that perpendicular plane will be the line of intersection that we just found, the spine of the notebook. So let's see if we can do that on the stereographic projection. Before we begin, I'm going to do a couple of little housekeeping tasks here. First thing is that, and I'm going to shift while selecting to select multiple objects. A couple of these objects have ended up in the rotating WolfNet layer, so we'll move those to the work layer. Move there. And then a couple more things that we created. These are our X's here. They're called U's because they're clones of objects deeper down in the layer. We're going to move those into our work layer as well. So there we go. And then the other little housekeeping task to do is these lines I feel are a little thick. We like to use reasonably thin lines for drawing when we're doing this by hand. I recommend that you keep your pencil sharp so that you can draw lines that are less than 0.5 millimeter wide. So let's see how we go about doing that in Inkscape. So this number down here at the bottom left hand corner of the window, that is our line thickness. If we click in there, it brings up a palette where we can control the line thickness. And I'm just going to do a few clicks down here. We could enter any number we wanted in here. So I'm going to take these down to 0.445 of a millimeter, which I think is probably a good size. Then I'm also going to zoom in here. That enables me to see that maybe my X is a little bit to the left of where it should be. I'll see if I can nudge it over just a little bit. I think I need to do this by hand because the mouse key is moving a little bit too far. So there's the X a little bit more precisely. I don't think that makes any difference to the numbers, but it's a little bit more precise. So zooming out again using the minus sign key, what we want to do now is to plot that perpendicular plane. So we need to use that green X that I just had selected. We need to use it as the pole to the plane that we're going to draw. So I'm going to get hold of the net, click once, click twice to bring up the rotation handles. And there's a little dot here that represents where the poles go. It's on the opposite side to the curve here that represents where the great circles go. So I want to turn the net around until that dot is down here at 186 degrees. And then you'll see that the left-hand straight radius of the net goes right through my green point there. We can zoom in, and that's nice and close. So now we're going to use that as a pole to a great circle. So this pole is plunging at 7 degrees. How far is it from the center of the net? Well, it's going to be 10, 20, 30, 40, 50, 60, 70, 83, 90 minus 7. So our plane is going to have to dip at 83 degrees. So I'll just move this down a little bit and zoom in. And then we can go here and we can grab our Spyro tool. Might want to zoom out just one click here because I want to see both sides of the net. And I'm going to click once at the top point of the net. I'm going to click 7 degrees away from the vertical, or alternatively, if you like, I'm clicking 10, 20, 30, 40, 50, 60, 70, 83 degrees of dip here, and my third click is going to be at the bottom point of the net, and a right click to let go. So this one is filled with green, which I guess is the last color we were using. So we'll turn off the fill, and we'll turn on, by holding down the shift key, we'll turn on a green line. So there is our green line. You'll see it goes right through the two poles to the planes that we plotted in the first place, the black plane and the red plane. And that, of course, is how it should be, because those two poles are perpendicular to those two planes. That's what a pole is. And a green plane is the plane that is perpendicular to those two planes. So it contains all of the lines that are perpendicular to the first two planes, including those two that we plotted. So this is all as it should be, and we have succeeded in plotting the plane perpendicular to those two other planes. The only thing remaining is to determine what is the strike and dip of this plane. So we can read off its dip because that is the number of degrees that we have to go down the bowl until we hit the great circle. And we already measured that. It's 83 degrees of dip. What about the strike? Well, here is the arrow that represents the top point of the net, and you can see that it's at 270.246, so it's 276 is the strike, and the dip is 83, and it's dipping very steeply, but it's dipping to the north. So we'll add that to our write-up here. So I'm going to type it down here, perpendicular plane, and we said the strike was 276, and the dip, I use a slash for planes, is 83. And if I want to, I can add north to here. Now we have outlined text because we were using a grid outline for our great circles. So what I suggest we do is that we fill in the text here, and then we turn off the outline by holding the shift key down and hitting the big red X. And now we have a note of the orientation of our perpendicular plane. What about measuring the angle between the two planes? So if we were going to try to do this for real, we might take a protractor and place it on the plane perpendicular to our two notebook covers and try to directly measure with the protractor the angle between them. Now we can't usually do that with a geological structure which doesn't come with a convenient flat end, but we can see about how to do that on the stereographic projection. I'm going to add to my diagram some labeling here. So the distance between these two poles, and I'm going to use the regular pen tool here. So I'm going to drag out a handle here, and I'm going to drag out a handle here. That will give us a curved line here. I'm going to click there. I want to, I think, make this line black, so I'll do Shift and black, and I want it to have no fill. And I would like to add arrows to the ends of it. So let's have some arrows. These are available in the same place where we adjusted the thickness of the line. And then I can write in my angle here, and that angle was 58 degrees. And then alternatively, we can measure the distance between the intersections. So here it is. And we'll add the arrows again. And this time, our angle was 122 degrees. Let's make those filled with black and with no outline. There we go. So now our two versions of the angle between two planes are shown here. So why do we get these two different answers? So I'm going to make a quick sketch to try to figure this out. And we have a plane that's dipping to the west, the one that we colored in red. So maybe in a cross section, it's going to look something like this. Here it goes. It's dipping only 21 degrees. It's dipping quite gently down to the west. Let's make its outline red. There it is. And then we have another plane that is dipping more steeply down to the east. Here it is, and that one is colored green, and we're trying to figure out the angle between these two. Is it 58 or is it 122 degrees? So we can crisscross these two lines, and of course there are always two angles between a pair of lines like this. There is an acute angle in here, and there is an obtuse angle, one that's greater than 90 degrees here. And those two angles are always going to add up to 180 degrees. So we can see our two angles here, 58 and 22, do indeed add up to 180 degrees, as we would predict. And which is the answer to a particular geological problem requires you to visualize how the planes are related in 3D space. And that's why it's important to be able to visualize that stereographic projection as a bowl sunk into the ground, because these two planes might be joined as a fold lying on its side here, what we might call a recumbent fold, or they might be joined like this, maybe to make an upright fold or a steeply inclined fold. So it always requires a little bit of imagination to figure out which is the number that you want in the case of measurement of an angle between two planes. The stereographic projection will always give you two answers, one of them less than 90 and one of them greater than 90, unless of course the angle between the two planes is exactly 90 degrees, in which case they'll both be the same.